Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapience Education. Today I am going to discuss about the electromagnetic induction. So this is part 2 video. I have already discussed lots of topic in part 1, so you can go to that video, part 1 video. Now let us discuss today as a Lenz law. Basically what is Lenz law you need to understand here. According to this law, the polarity of EMF induced in such that it tends to produce the current which oppose the change in a magnetic flux that is produced. What do you mean by this? As we know that if any loop is there, if any conductor is in the form of loop is there, and if you change the flux around it, let us consider, if you change the flux around it, that is this is your north pole and this is your south pole, and it is creating a magnetic field. As it is a magnet, so it will create a magnetic field. Now when you move this bar magnet toward this or either in this direction, so what will happen? Change in flux will happen. Change in flux will happen. Flux will happen, right? If change in a flux will happen, so what will happen? A current will be induced. Now the thing is that what is the direction of current? What is direction of current? This is very big question around it. So that's why Lenz has come up with a solution about the direction of the current. So if you want to understand that what is the exactly direction, what is the exact direction, let us consider this is a loop. Just I am making single loop, and now this is north pole as well as this is south pole. Okay. Now what will happen if you move this forward? So what will happen? This circuit will oppose it. This circuit will oppose the movement, and the only way that it can oppose the motion is that it should behave as a north pole, and it should behave as a north pole, right? If it should behave as a north pole, let us draw it in a proper way. So let us suppose it, if it will behave as a north pole here, so it means that current will move in the anti-clockwise direction. Got it? So current generation or the induced EMF or induced current will be in such a way that it will create a north pole and it will oppose the motion. So Lenz has given the very simple definition that the polarity of EMF induced is such that it tends to produce a current which opposes the change in a magnetic flux. So I hope you have understood this. Again, I am telling you, according to this law, polarity of induced EMF is such that it tends to produce a current which opposes the change in a magnetic flux that produced it. Now we will use the different case here. See, this is north pole and south pole. So what will happen when it will move here in this direction? So it will behave as a north pole, so that it will oppose it. Now just one more case may happens, that if it will move in this direction, so what will happen? It will behave as a south pole. South pole means it will reverse its current, so that it will again try to stop the movement. So the always current will be induced in such a way that it will always oppose its cause or creation. The main creation factor for this is the movement of the north and south magnet or a flux change. So it will always try to oppose the change in a flux. See here, now motion. So see here, this is in the movement in this direction. So it will behave as a south. See, south pole. So it will, the direction of a current will be like this. Now see here, it is at a rest, but this coil is moving. So it is at a north. So it must also behave as a north pole. So this will only happen when the current is in this direction. Now see here, this is your north pole and it is moving away, so it will try to oppose. So if it is your north pole, so it will try to make it as a south pole. Understood or not? One more thing is that you need to find the polarity. So it is very important that what is the polarity. Suppose I am telling you that the current is moving in this direction. So what how it will behave? It will behave as a north pole as well as or south pole. So just you need to do a simple thing, that is either you can make a north n or south here. So let us just I am trying to make it as a north pole. If I will write here north and just take it arrow, so what happened? It is just opposite to the current. It means that our assumption is wrong. It means that it is your south pole, right? Now if now see here, if I'm making here, just you write whatever you want. If I'm making a south, so see here, direction of s sync with this, it means that it will behave as a south pole. So this is how you need to find the direction. Okay, now this may happen that if both the loops and magnets are relative motion. See here, if both are in motion, so what will happen? If v1 is greater than v2, so what will happen actually? What will happen? V1 is greater than V2. It means that this coil will move toward this. If this coil will move toward this, it means that it is your north pole. So it will also behave as a north pole so as to oppose it, right? So this is how you can find the direction. Now, conservation of energy and Lenz's law. The very important thing that how we understand the conservation of energy and Lenz's law. See here, a conservation of energy and Lenz's law are closely related to each other. According to Lenz's law, the direction of current will oppose the magnetic flux or flux change. So we have studied in here that whenever current will be produced, so it will always try to oppose the cause, right? So it means that to produce current, we need to produce a current, we need extra effort. Why extra effort? Because when you move this, so what will happen? It will try to oppose. So it means that we need an extra effort. So this extra effort needed to overcome the opposing force, and increase in the magnetic flux result in increase in the induced current. Due to this additional work, this extra effort is converted into electrical energy. Now earlier what happened? If North Pole and South Pole are not sufficient to produce a current, you need to do work. It means that without work you cannot generate any electricity. So this is why we can say that conservation of energy and Lenz's law are both related. It means that it provides a good solution that yeah, energy is conserved here. You cannot say that energy cannot be conserved. So here energy is conserved, right? Now see here, so we have already discussed about this direction movement. So when it is moving in this direction, so this is your north pole, so it will also behave as a north pole, right? So this is north pole, so this will also behave as a north pole. So the current will come down as it will go move in this direction. So this is north pole, so it will not become it will become south pole. Why? Because it will try to stop, right? So that's why current will be in upward direction. It will behave as a south pole, right? And this direction it will behave as a north pole. Now see, one of the question we can do here. Now one of the question we can do there, in the given figure, a bar magnet quickly moved toward the conducting loop. Predict the polarity of a plate A and B. Now if it moves, so what will happen? Try to understand or figure out. So it will behave as a, if it is north pole, so it will also behave as a north pole, right? So when it will behave as a north pole, uh, so what will happen? See here. So it will be anti-clockwise. So current will come from A and it will enter to B. So A will be act as a positive. A will be act as a positive terminal and B will be act as a negative terminal. So this is the way you can also solve this type of question. Okay. Now next is your energy consideration or qualitative study. It is sometimes also known as motional EMF. Motional EMF. Okay, what exactly happens? There is a magnetic field and around this there is a circuit we have taken, and there is a also a wire which will move in this direction or this direction. Okay, so this may move. Now let R be the resistance of the movable arm and PQ of the wire. So R is the resistance and PQ of the wire irregular conductor. We assume that the remaining arms QR, RS and SP have a negligible resistance. So let us consider it has a negligible resistance. Thus the overall resistance of the rectangular loop is R, and does not change. The PQ is moved. Now the current I in the loop is given by E by R. Okay. Now let us see here. Try to understand. Try to understand here. Let if you see or observe this circuit, so in this circuit or there is no current, the magnetic field is perpendicular. Now if you try to find a flux, so flux, what is the formula for flux? B dot A, that is BA cos theta. BA cos theta. Here theta is equal to 0 degree. Why? Because area vector and the magnetic field has the same direction, so theta is equal to 0. So we can write flux, magnetic flux is equal to B into A. So what is the area? What is your area? So if this length is L and this distance table is X, so what will happen? We can write as area as B into L into X, right? B into L into X. Now if we try to find EMF, so EMF is equal to how much? We can write here EMF is equal to minus d phi B by dt, right? So here minus d phi b means B L into X divided by dt. We can write it like this. So finally EMF can be written like this. EMF can be written as like this, minus B L dx by dt, and now dx by dt is your velocity, so minus B L V, right? Minus B, or minus dx by dt can be written as velocity because it will be in opposite direction. So finally EMF is equal to BLV. So this is known as motional EMF. This is known as motional EMF produced. Now if you want to find a current, so current is equal to EMF by resistance. So if the resistance is R, so finally current can be written as BLV by R. Okay. Now force is equal to force is equal to, we know that B into I into L. So if you want to find a force applied, is then you just put the value B into current I into Ln. So current, we have a value of a current, just now we have found current value is BLB. So it will be B into L into B by R into L. So finally what will happen? B square L square B by R. So this is your force. This is your force. Okay. Now power. If you talk about the power, so power is equal to force into velocity. So here if you put the value of power, force, so force is equal to B square L square B square sorry, it is your power is equal to, see here, force into velocity. Force has a value b square L square v by r into v. So finally power you will get as b square L square v square by r. I hope you have understood in that how much power is being generated when you put this coil like this. Okay, so I hope you have understood this. So in next class we will talk about the mutual inductance. Okay, inductance, we will talk about mutual inductance. Thank you for watching my video.